let's get started here. I should mention, I should have the next test review for you guys sometime soon. I just need to put the thing together and then post it for you. So, Friday, which is the 18th, yeah. So, I'm pretty much following what's on that schedule, so, you know. Chapter 2 and 3, yep. Which is just a fancy way of saying lines. How to solve equations involving lines, and sometimes more than one. All right, so let's see here. Let's do a couple warm-up examples. Let's solve 4y plus 2x equals to 18 and minus 8y plus 3x equal to minus 15. Do you guys smell anything in here? Does it smell like some kind of solvent or something? Like a cleaner? You put your what? What'd you say? Oh, no. That would be, I'm not that. My nose is not that finely attuned. There's no way I would be able to pick up on that. No. No? Everybody cleans their room with bleach. What's wrong with you? What? No, I'm just kidding. I don't. I almost never clean my room. Actually, here's a funny story. When I was in graduate school, and my future wife, as it turns out, came to visit my office for some reason I forget, and I like almost never clean my office, like never, right? But I just happened to have cleaned and organized my office before she came to visit. So like, I tricked her. She thought she was, she didn't realize what she was getting into, because she stumbled into like a very unlikely event, which was me organizing and cleaning. But anyway, miracles aside, how do we solve this? Times the top by 2. I can be even lazier though. How about this? What if we just subtract the top equation from the bottom equation? Like, let me just put it down here. Let me write it down here. 4y plus 2x equals to 18, right? If I just, same equation, right? And I totally agree with you. We could multiply by 2. I'm just pointing out you could be even lazier. Subtract them, you get minus 12y. Oh, wait a minute. I'm a dummy. Let's do what you said. Oh, I'm sorry, guys. Yes, thank you, Stuart. Your idea is better. My idea was just making a mess. Thank you. So you said multiply the top equation by 2, right? So that gives us 8y plus 4x equals 2 times 18, 36, right? And then we can add these equations like so. The 8y and the minus 8y cancel. We get 7x equals to, what'd it say? 21? Yeah. So x equals to 21 over 7, also known as 3. And then, let's see here, then we've got like 4y plus 2 times 3 equals to 18. So I'm plugging the x we found back into the first equation to try to figure out what y is. This gives me 4y is 18 minus 6, which is 12, thank you. Which gives me y is 12 over 4, also known as 3. So solution is 3, 3. Very good. Okay, example 2. Find solution set of 2x equals to 4 and x minus 1 equals to 0. Oh, I'm sorry. I'm an idiot. My bad. Sorry, 2x equals to 4y and x minus y. I may still have it wrong. Give me a second here. That's supposed to be a 2 on both sides here. My bad. There we go, finally. I was solving a test before this period, and it used a lot of my mental energy, and obviously I'm still not recovered. I don't like my students' chances at that test, now that I think about it. Like, if it hurt my head, I already know the stuff. I wonder what it did to them. No, your tests they're harmless. It's fine. Let's see here. So then, I mean, these equations are presented kind of funny, aren't they? But if we write them like this, we've got 2x minus 2y equals to 0, right? And we've got x minus y equals to 0. What happens, so this is a nice one to do like substitution for, right? What's the second equation say? It says y equals to x, right? And what happens if I plug that into the first equation? We have 2x minus 2y, but 2y is x, right? So what do we get? 0 equals to 0. Is this true? Well, yeah, I mean, I think this one's just true, right? I mean, you don't need, who's calling me? Oh, it's probably my extended warranty people again. Ignore them. This is true, right? For any x, right? So what's the solution set here? Solution is, what is it? It is x comma y such that y equals to x. Or you could also write it like this. It is the set x comma x such that x is, a real number. Let me just write it in words. X, a real number. Oh, either is fine, really. I mean, you could, on this kind of problem, probably if you just told me the solution is y equals to x, that would be also another way you could say it. What's going on here? This example is kind of funny, isn't it? So what's going on here is that these two problems that we're given, these two equations, right? What are they? We've got 2x minus 2y equals to 0, right? What happens when you multiply the second equation by 2? Yeah, it's actually the same equation given twice, right? So there's different ways to look at it. One way to look at it is, you said this is two equations and two unknowns, but, kind of it's really just one, isn't it? So when the two equations are in fact the same equation, the same exact equation, then you get an infinite solution set. Graphically, what's going on is they're the same line, right? Like the blue line is y equals x. The yellow one is y equals x. Anything on this line, y equals to x, solves the equation. And so that's why the solution set is everything, x comma x, of the form x comma x. Okay? So the lion's share of the examples we've looked at before have been what? A unique solution, right? So geometrically, that corresponds to two lines that have different slopes and they intercept at just one point, right? The other thing that could happen is I could be like, find solution set of x minus y equals to 1, and 2x minus 2y equals to, I don't know, 10, right? So what happens if we take the second equation and we divide by 2? What do we get? We get x equal, yeah, 10 over 2, which is 5, right? So we've got x minus y equals to 5, but we also have what? X minus y equals to 1. Can you have x minus y both equal to 1 and equal to 5? No, I mean, that's impossible, right? So this is not equal to. So that shows you there's no solutions. Impossible to solve both equations at once, right? Impossible to simultaneously solve both. And what's going on geometrically? Like, what's the story here? So the first one, right? I'll make it blue. This is y equals to 1 minus x, right? The second one is what? It's y equals to, you can see it better down here, right? Y equals to x minus, well, 5 minus x, right? Wait a minute, my bad. I'm sorry, that's x minus 1. I'm an idiot. So this one's x minus 5. I warned you guys. See, if I solve this top equation for y, I flip the 1 in the y, I get x minus 1 equals to y. This one, if I solve this for y, I flip the 5 in the y, I get x minus 5 equals to y. Graphically, what are those? We can graph those, right? So they both got slope 1. The orange one has a y-intercept of minus 5, right? The blue one has a y-intercept of 1. But they just go on and on. There's never a point which both lines meet where both equations are true. The graphs don't intersect. In this case, the answer is the solution set is the empty set. So solution set is, we use this notation sometimes. It's the set with nothing in it, right? Now your homework might have this symbol. Sometimes they use that for the empty set. In words, we say there is no solution, okay? So any three of those I will accept credit for, if this kind of thing happens. And you say, if I say solve the system if possible, in this case you say, hey, it's not possible. That's the answer. Although, play with words for a second. Even though there's no solution here, we did just solve the problem. Right? Sometimes the solution to a problem is understanding it can't be solved. It sounds kind of funny when you say it out loud, doesn't it? Okay, so what are our methods? Graphical, substitution, elimination, right? So let's look at some word problems. Oh, I'm supposed to talk about, my bad, I keep forgetting. I got to come back parallel and perpendicular, right? So example 4. Find equation of line perpendicular to y equals to 3x plus 2, which goes through, you give me any point, guys. Let's say 2, 6, okay? So we're looking for a line that goes through the point 2 comma 6, right? So the line that we're looking for, let's say has slope m, right? We want with slope m through 2 comma 6. So we already know point slope, right? So we can say, well, what we're looking for is y is equal to 6 plus m times x minus 2, right? That's the equation we want. But what's our choice of slope, though? That's the question, right? What slope? We want this line to be perpendicular to 3x plus 2, right? So what is the slope of a perpendicular line? What was the definition? So we want perpendicular to y equals to 3x plus 2, right? So what's the slope of the y equals 3x plus 2 line? It has slope 3, right? The perpendicular line has the negative reciprocal of that slope. So what we're looking for is 6 minus 1 over 3 times x minus 2. So it has slope minus 1 over 3. So to find the perpendicular line, we take the slope that we have, and we take the negative reciprocal of it, right? And that is the line that we're looking for, which we could clean up a bit. That's what? That's, I mean, you can leave it like this if you like. It's fine. I mean, it depends on the question. If we wanted to write the answer in like mx plus b format, this would be what? Minus 1/3 x. And then I need to add what? I need to add 2/3 to 12. There's a slope of 3 here. Here, it's fine. So 6, how many thirds is 6? It's 18, right? So I think we have a total of 20 thirds. Here's the graphical side of what's going on right now. Y equals 3x plus 2. It's got a y-intercept of 2, and it's got a slope of 3. It looks something like this. Right? Slope, the intercept is 2, the slope is 3, over 1 up 3. And this other guy, it's got a y-intercept of 20 thirds, which is like 6.6, 6.66. Funny. I mean, not funny, serious. Here. 2. This is an evil example. Let's see here. There you go. This is 6.6666. And the slope is minus 1/3, right? Which means that we go, the rise, we go down 1 and over 3. Down 1 and over 3. So that looks like this. And this line goes through the point over here of 2 comma 6 as advertised, right? So there you go. That's the line we're looking for, perpendicular to the given line that goes through a given point, right? So the key idea here is if we're looking for the perpendicular line to a given line, we got to use this idea, negative reciprocal slope. Lightning round. Given line. Perpendicular line slope. X plus y equals to 2. So this gives us what? What's the slope on this line? Y is equal to 2 minus x. The slope is minus 1. Perpendicular line slope, m, minus 1 over minus 1. Perpendicular line would have slope 1. If we had y is equal to 4x plus 37, the slope would be 4. The perpendicular line slope, minus 1 over 4. Nothing to do with 37. It's all about the slope. If we had 3x minus 8y equals to 0. This would give us y is equal to 3/8 x. What would the perpendicular line slope be? The perpendicular line slope would be minus 1 over 3/8, also known as minus 8/3. So to find the slope of the perpendicular line, you have to identify what is the slope of the line that you're dealt, and then take the negative reciprocal of that. That gives you the slope of the perpendicular line. Most of my example 4 was just that other stuff that we always have to do, like to find the equation, you got to link it to the point and do the algebra steps. So this is the story of perpendicular. What if you wanted to have, say, like in my example 3, parallel line? What would the slope of a parallel line be? A line which is parallel to this has slope minus 1. Parallel line slope is much less exciting. The line which is parallel to 4x plus 37, the slope of the parallel line must be 4. The slope of a line which is parallel to 3/8 x is 3/8, yeah. That's pretty much it. I mean, you just have to work out the logical. There's a dozen different questions you can ask about this, right? Because there's a lot of different ways that you could ask a question about a line, but they all come back to these two concepts: perpendicular, negative reciprocal of the given slope; parallel, same slope, right? If two lines cross but they're neither parallel nor perpendicular, what do you call that? You're like, you call it neither parallel nor perpendicular, right? I guess you do that. You could also call them skew. I'm not sure. I think skew might also include perpendicular, though. I don't know. Anyway. Word problems. To the word problems. What? Oh. All right. Let's start with number 1. Enough that you can't ignore them. Let's see here. So, let's do number 1 here. An office supply store recently sold black printer ink cartridge for $17.99. All right. And color cartridge for $23.99. At the start of a recent fall semester, a total of 50 cartridges were sold. Wow, that's a lot of cartridges. All right. For how much? $965.50. All right, great. The question then asks, how many of each type were purchased? How many black? How many color? Ink. Okay, so, all right, how are we going to solve this problem? So any word problem, right, the first thing that you want to do You know, if you can't just figure it out in your head by looking at it, you know, sometimes you can do that, right? But the numbers here are a little bit ugly, so I probably just can't guess it, you know. And even so, guessing is dangerous because it's hard to get partial credit on a guess, isn't it? But anyway, might as well give labels, right, to the things we don't know. What are we trying to figure out? We're trying to figure out the number of black and the number of color cartridges. So let's call that X and Y. You know, just, we got to call it something. So we'll call this X, and we'll call this Y, right? So that's the first thing. Choose your labels, right? And then once you've chosen the labels, then you have to go back and read the question over and say, what equations do I know about those labels? For example, I know a total of 50 were sold, right? So that tells me that X plus Y is equal to 50. Right? What else do I know? I know that the amount that the cost was $965.50, right? So how do I get the cost from X and Y? Yeah, 17.99X plus 23.99Y, and that's the cost, right? But we also know it's equal to 965.50. Now these kind of problems, I almost always use substitution for these. Because, I mean, you could multiply the top equation by 17.99 if you want. What do you guys want to do, substitution or elimination? It's your class, you pick.
What is easier?
Yes.
That's not answer.
It doesn't matter.
Substitution.
Okay. So this says that Y is equal to 50 minus X. What I do is I take that and I plug it in right here, right? And that gives me 17.99 X plus 23.99 times 50 minus X equals to 965.50. If you like, we could, well, I won't do, well, I don't know. You know, if you get tired of the decimal points, you can always just take this thing and multiply by 100 and get rid of the dots, but I won't, I'll behave. So then I need my calculator, right? So I got something like 17.99 minus 23, maybe I don't, 23.99 times X equals to 965.50 minus 50 times 23.99. So what I did was I grouped the stuff with X on the left-hand side, and I moved all the numbers to the right-hand side. Because there's a, this times that is a minus 23. Yeah, so I'm collecting all the X things together, and then the 99s cancel, right? I'm left with 17 minus 23, which is like minus 6. So I've got, this gives me minus 6X. What's 50 times 23.99? $1,000 what? 1,199.5. All right. So we get 965.5 minus 199 point. So, oh look, the 0.5s cancel. And what does that leave us with? I don't know. I'm not going to try to do that in my head. No good will come of that. especially today. 965.5 minus 1199.5. Whoa, minus 234. That worked out nice. So x is equal to minus 234 divided by minus 6, which is what? 39. So apparently they bought what? 39 black ink cartridges, and how many colors? How many colored ink cartridges then? If there are 50 total, 39 are black, there must be 11 color cartridges that they, so 39 black and 11 color inks. Is good? Yeah. Let's see here. Oh. Let's do another one here. Student makes a $10.25. This is my second example. $10.25 purchase at the bookstore. Irrelevant. Using a $20 bill, right? The store has no bills and gives the change in quarters and 50-cent pieces. What? Okay. Using quarters and I've forgotten how to write cent. 50, is it like this? 50-cent pieces. You know, it's always nice to find those, isn't it? I don't know, it just makes me happy if I find a 50-cent piece. All right, then we're also told that the store gives 30 coins in total. So the question is, how many quarters and 50-cent pieces given? I mean of each, of course, right? So what do you guys think? What should we label? What should we label here? Quarters are X. Okay. I like it. What equations do we know? We know x plus y equals 2. Right? This sentence here tells me x plus y equals 2, 30. Right? But we also know that the change was given. Right? What is the change here? Now, this is the tricky part about this problem. You have to figure out what the change is. They don't tell you it. They say he made a $10.25 purchase, right? They didn't say that the bookstore gave him $10.25 change, did they? Right? It's like, haha, we trick you. So this means, by the way, that we had a $9.75 a change, right? Right, because 20 minus 10.25 is 9.75. So we also know, and so we know 9.75, right, is the change. And how do we get that from x and y? Well, in fact, instead of saying 9.75, let me just go ahead and say 975, right? That's how many pennies, isn't it? You guys mind if I do that? 975 cents. See, because then I can write the following equation. 25x, that's how many cents in quarters, from the quarters. And then 50y, that's how many cents that you get from the 50-cent pieces. So this equation is in cents. You could also write the equation in dollars, you know. But if you wrote the equation in dollars, it would be 0.25x plus 0.5y equals to 9.75. It's the same equation, just divide by 100. I like to think in cents for this problem because I do not enjoy the decimal jibber jabber over here. So now what? Oh, well, two equations, two unknowns, right? So we take the top equation and we solve it for, what we got? Y 30 minus x. You take that, right? And you plug it in here. And what does that give you? It gives you 25x plus 50 times 30 minus x equals to 975, which then gives me 25x minus 50x plus 1500 equals 975, which gives me 25x is equal to 1500 minus, I flipped the sides this time. So I moved the 25x to the other side and I subtracted the, anyway, you get this equation. 1500 minus 975, that's like 1500 minus 1000 plus 25, which is 500 plus 25, 525. 525, well, everyone knows that 525 is, wait a minute, no, it's not. I'm thinking of 625. No, 525 is, 520, yeah, I'm thinking 525 is 25 squared. 525 is 25 squared, actually. So when you divide this, you get x is equal to 25, which tells me that y is equal to 5. So 25 quarters and 5 50-cent pieces, which you can check right quick because 25 quarters is $6.25. $6.25 plus 250 is 975, so it checks. But, yeah. Sorry, I sped up a bit. I want to make sure we have time for one more question. I think with these three examples I'm showing you, it's pretty much all of these question types in the homework, if I remember right. You like this one? I like this one more too. But this one's also nice because it's got some trains in it. Train leaves the station north at a speed of 75 miles. Northbound train, 75 miles per hour. All right. And 2 hours later, right, second train leaves on a parallel track north at 105 miles per hour. All right. How far from the station will they meet? All right. So what do you guys think? So the idea here is we need to come up with the equation of motion for the trains, which is just a fancy way of saying we need to write, like here's a picture, right? So we've got train A, right? It's going at 75 miles per hour, right? And then later, you got train B, and it's going at 105 miles per hour, right? So this is at some time t. Right? So here's the deal. Distance equals velocity times time. Right? This is the deal. And so here's the situation. The y for A is equal to 75 times t, because that's the time that the A train has gone. We're putting t in hours, right? So there it is. Now, what's the y for the B train? It's 105. But t wouldn't be honest, because at time t, how much time has... So this is really supposed to be the time of the trip for that train, you know? How much time has elapsed for that train? So like, for example, at 3 hours, the train B has gone 1 hour's travel, right? And so the formula you want is t minus 2 here. All right. So that's the equation for the A train and the equation for the B train. That's where they are, distance from where they started, going north, right, at time t. What are we looking for? We're looking for the time when they meet. That's when what? In our notation, that's when YA is equal to YB, right? They meet when they have the same the same distance, right? So what we need is 75t equals to 105 times t minus 2. And so we can solve that, right? Because that's 75t minus 105. Well, sorry, let me just... So we got 75t equals 105t minus 210, which gives me 105t minus 75t equals to 210, which gives me 30t equals to 210, which gives me t is equal to 210 over 30, also known as 7. So the result is that the trains will meet 7 hours after the first train left the station, or 5 hours, if you like, after the second train left the station. So... Yeah, and the question was not the time, though. The question was how far. So if that's the time, 7 hours, how far is it from the station? We have to take 7 times 75, right? And that's supposedly going to be equal to 105 times 5, right? Those should be equal. That's where they meet, wherever that is, whatever that number is, 7 times 75. 525. Of course, 5 times 105, also 525. So they finally, end up at the same place 7 hours later when they're both 525 miles from where they started. So the answer to the question in the homework is 525. So anyway, we can do another one of these next time. I know that this one is a little bit, these are much easier, right, than this, I think. Yeah. Have a good weekend.